Hi guys, welcome to today's numeracy tutorial. Our learning objective today is adding fractions. We already know and understand that fractions are special numbers that let us show parts of a whole. A fraction that shows an amount greater than a whole can be written as an improper fraction or a mixed number. An improper fraction is one where the numerator is greater than the denominator. A mixed number, or mixed fraction, is one showing a whole number and a part fraction. Today, we are adding fractions. Before we begin, let's get warmed up with our 5-question brain gym. Here are your 5 questions. Pause the video now and give them a go. I notice the sequence in question 1 is descending. It's getting smaller. It starts with the whole number 2 and then is made up of mixed fractions. You might have used a number line to help you recognise that the sequence is decreasing in quarters. So the next number in the sequence will be 1 and then 3/4. Question 2 is an equivalent fraction question. You needed to remember the golden rule of equivalent fractions. Whatever multiplication or division is carried out to the denominator, you've got to do exactly the same to the numerator, or vice versa. Look at the pattern between 3 and 12. I know that 3 multiplied by 4 will give me 12. So if I've multiplied 3 by 4, I've got to multiply 2 by 4. I get the numerator 8, and the fraction is 8/12. What is the area of a rectangle with 3 rows of 2 squares? I know to find the area of the rectangle, I need to multiply the 2 adjacent lengths. This rectangle would have a length of 3 and a length of 2, so 3 times 2 is 6. Question 4 is a place value question. 1,000 more than something is 3,481. I know that my answer needs to be less than 3,481. It's going to be 1,000 less. So the answer is 2,481. Question 5, as normal, is our time question. We are beginning to understand that the clock face is split into 5-minute intervals. If we look really closely, you can see that the minute hand is pointing to the 3rd notch past 12. That means it is 3 minutes past 6. We write that in words, and as a digital time, it's 1:06. Now we are ready to focus on our learning objective. Let's learn a little bit about how to add fractions. Look at the picture here. By the end of this tutorial, you'll be able to come back to this question and complete it. Here are 2 fractions. Let's show how we add these 2 fractions together using bar models. Each bar is split into 7 equal parts, showing sevenths. The top bar has one section shaded to show 1/7, and the bottom bar has 2 sections shaded, showing 2/7. If we move the 2/7 to join the 1/7, then we have a total of 3/7. We can see that 1/7 add 2/7 equals 3/7. Here are 2 more fractions. This time we are adding 2/7 and 4/7. Oh, hi Greg. Greg says that 2 add 4 is equal to 6, and 7 add 7 is equal to 14. He's pretty confident that the answer is 6/14. Do you agree with Greg? Pause the video and have a think. Let's draw 2 bar models to show our fractions. Both bars are of equal size and both show sevenths because they have been split into 7 equal parts. The first bar has 2 sections shaded. This represents 2/7. The other bar has 4 shaded parts to represent 4/7. To add the fractions together, we can combine the sevenths so that we have 6/7 altogether. We're showing that on the bar model. So 2/7 add 4/7 is equal to 6/7. Sorry, Greg, it looks like you're not right today. Can you see what mistake Greg made? Let's think about this a little further. Would 2 pennies add 4 pennies equal £6? No, of course not. They're not equal. we need to pay attention to exactly what it is we're adding together. So 2 pennies add 4 pennies is going to equal 6 pennies. They're all pennies. In just the same way, 2 ones add 4 ones, well, that's going to equal 6 ones. We can say that 2 tens add 4 tens, it's equal to 6 tens. 2 hundreds add 4 hundreds. You know the answer to this. 6 hundreds. Well, it's exactly the same for fractions. We need to pay attention to what we're adding. 2 sevenths add 4 sevenths is equal to 6 sevenths. We're adding together sevenths. The denominator tells us what it is that we're adding, and the numerator tells us how many we're adding. How might we use a bar model and a part-whole model to show the addition 2 ninths add 4 ninths? Pause the video now and have a go. Let's start by showing our 2 fractions on bar models. Both of these bars are equal size and they have been split into 9 sections each, so they are showing ninths. The top bar model has 2 sections shaded, representing 2 ninths, and the bottom bar model has 4 sections shaded, representing 4 ninths. Next, we can show the 2 parts on our part-whole model. Now let's add the 4 ninths to the top bar model with the 2 ninths. We can see from the bar model now that 6 sections are shaded. This means 2 ninths add 4 ninths. Well, it's equal to 6 ninths. Here there are 3 addition calculations. Each time we have added 2 fractions together. You can see alongside each calculation a bar model with 2 colours showing each of the fractions. Look carefully at each calculation pair. What do you notice about all 3 calculations? Pause the video and have a think. Did you notice that for each of the calculations the numerators were added together but the denominators remained the same? Here's another 2 fractions for you to add. 3 fifths add 2 fifths. Can you draw a bar model to help you? Pause the video and have a go. Let's show both of the fractions on bar models. Here, each bar is of equal size and both are divided into 5 equal sections. The top bar model has 3 sections shaded. This represents 3 fifths and the other bar represents 2 fifths. Let me add the 2 fifths to the top bar. Altogether I have 5 fifths. And what do you know about 5 fifths? It's equal to 1 whole bar, so we can write just 1. As before in our previous tutorial, it's always best practice to convert fractions to whole numbers or mixed numbers when we can. The answer to 3 fifths add 2 fifths is equal to 1. Here's another example for you to have a try. Can you use a bar model to find 3 fifths add 3 fifths? Pause the video and have a go. Just as before, I'll represent the 2 fractions on bar models that show fifths. I can count the number of fifths to find out how many I have altogether. In total, I have 6 fifths. This is an improper fraction. The numerator is greater than the denominator. Let me show you. If we move 2 fifths from the second bar to the first, then we can see that 3 fifths add 3 fifths is equal to 1 whole and 1 fifth. 6 fifths is equal to 1 and 1 fifth. What happens if we need to add more than 2 fractions together? Here's a challenge for you to think about. 3 fifths, add 3 fifths, add 2 fifths. Leonardo says he will add the numerators together because the denominators are all the same. Each of the fractions are fifths. He has painted some bar models to help us. Pause the video and have a go at this. I will start by following Leonardo's advice. Because all the denominators are the same, I will just add the numerators. 3 add 3 add 2. Well, 3 add 3 is 6 and 2 more is 8. I must remember, of course, that I am adding fifths. So the answer is 8/5. I could, of course, use the bar models by counting up the number of shaded parts, and that would still show me that my answer is equal to 8/5. But look, 8/5 is an improper fraction. I must remember to change that to a mixed number. Leonardo is helping me. He has moved 2/5 from the lower bar model to the top, so I can see that 8/5 is the same as 1 whole and 3/5. Here are 3 more fractions to add together. Each of the fractions are fifths. Use a bar model to complete the calculation and see how many fifths there are all together. Remember, if the total is an improper fraction, you should try and change it to a whole number or a mixed fraction. Pause the video now and give this a go. Let's start by drawing a bar model for each of the fractions and shading the correct amount of sections to show the fractions. We can count the total number of shaded fifths and see that we have 11/5 altogether. I notice that this is an improper fraction. The numerator is greater than the denominator, so I know that the total of the 3 fractions added together makes more than a whole. We can show this by moving sections of the bar models, just like this. And now we can see that 11/5 is actually equivalent to the mixed number 2 and 1/5. I can find this out a different way by dividing. I can divide the numerator 11 by the denominator 5. 11 divided by 5 is equal to 2, remainder 1. In other words, 2 wholes and 1/5. Let's have a look at this calculation. What could the missing digit be? First of all, we notice that the denominators are all 7, so we can use a bar model with 7 equal sections to show sevenths. We shade 4 sections of the bar model to represent our first fraction, 4/7. We know that the total number of sevenths is 6/7, and we can show this on the bar model. How many sevenths have been added to 4/7 to get 6/7? Well, we can see that there are 2 missing sections. So 4/7 add 2/7 is equal to 6/7. The missing digit is 2. When the denominators are equal, I can find the missing fraction in this addition calculation by calculating the difference between the numerators. 6 take away 4 is equal to 2. Let's have a look at another example. Use a bar model to help you work out what the missing digit is this time. Pause the video and have a go. Just as before, you will have noticed that the denominators are all 7. We're adding sevenths, which means we can show our fractions on a bar model. Our first fraction is 4/7, so we can show that by shading 4 sections of our bar. Our total number of sevenths is 9/7. Can we show that on the bar? Oh no, we can't, because we've only got 7/7. We're only showing 1 bar. Let's draw another. Now we can show 9/7 on the bar model. How many sevenths did we need to add to 4/7 to get to 9/7? We need to find the difference. We can count on 5 sections, or we can subtract 4 from 9 to get 5. When the denominators are equal, I can find the missing fraction by calculating the difference between the numerators. 9 take away 4 is equal to 5. In our next example, and our final example for today, we are again adding sevenths. Because the denominators are all the same, we can again show this on a bar model, split into 7 equal sections. We begin by showing 4/7 on the bar. This time our total is 1 full bar and 3/7. We need to draw another bar and mark 3/7 on it. Now we need to think about how many sevenths have been added to 4 sevenths to make 1 whole and 3 sevenths. Again, we're finding the difference. We need 6 more sevenths. Our missing numerator is 6. Now we've come to the end of our tutorial today. Here's a quick recap of the main points of today's lesson. 1. When fractions have the same denominator, add them by adding the numerators together. Do not change the denominators. The denominators tell us what we're adding. 2. When fractions have the same denominator, bar models can really help you add fractions by counting the sections. 3. Always remember to change an improper fraction into a mixed number. Remember, a mixed number shows the whole and fraction parts. Now it's time for you to go and get independent practice. To learn, we need to practice, make mistakes, and learn from our mistakes. As always, best of luck today.